today I will be discussing about introduction what is bioplastic. Bioplastic are materials made from renewable biological resources such as plant biomass and can be either biodegradable or non-biodegradable. They offer a sustainable alternative to conventional petroleum-based plastics, aiming to reduce environmental impact and reliance on fossil fuels. Bioplastics are made from renewable resources like corn or sugarcane, reducing dependence on finite fossil fuels. However, not all bioplastics are biodegradable. Some require specific conditions to decompose, while others behave like conventional plastics if not managed properly. Their main goal is to lower greenhouse gas emissions and address plastic waste. But challenges like energy used during production and then used for raw materials must also be considered. In summary, bioplastics are a promising step towards sustainability, but their impact depends on responsible production and disposal practices. Next, I will discuss about objectives. There are 4 objectives, which are to comprehensively analyze the current state and prospect of bioplastics as a sustainable alternative to conventional plastics. This objective aims to examine the current use of bioplastics and their effectiveness as a replacement for traditional plastics, also explores their future potential, looking at whether they can become a widely accepted and sustainable option. Next, to assess the challenges and opportunities associated with the widespread adoption of bioplastics. This involves identifying the difficulties in adopting bioplastics such as production costs or special requirements for decomposition. At the same time, it highlights the opportunities they provide such as reducing plastic waste and promoting environmentally friendly practices. Then, to explore the potential of bioplastic to contribute to a circular economy and reduce plastic pollution. The circular economy focuses on minimizing waste through reusing and recycling materials. This objective investigates how bioplastic can align with this concept, helping to reduce waste and address the growing issue of plastic pollution. Next, to investigate the environmental, economic, and social impacts of bioplastic production and utilization. This objective examines how bioplastics affect the environment, economy, and society. It looks into whether the production process is environmentally friendly, whether bioplastics are cost-effective, and how they influence communities in terms of benefits and challenges. Next, for importance of sustainable bioplastic production, there are 3 key points of this title, which are reduce reliance of fossil fuels. Sustainable bioplastics are made from renewable resources like plants, unlike traditional plastic, which are made from fossil fuels such as oil and natural gas. By using bioplastic, the demand for fossil fuels can decrease, helping to conserve these non-renewable resources and reduce dependency on industry that contribute to climate change. Then, lower greenhouse gas emission. The production of bioplastics typically generates fewer greenhouse gas emissions compared to conventional plastics. This is because the plants used to make bioplastic absorb carbon dioxide during their growth. As a result, sustainable bioplastic production can help reduce the overall carbon footprint and mitigate global warming. Next, promote a cellular economy. Sustainable bioplastics align with the principle of cellular economy by encouraging the reuse, recycling, and proper disposal of materials. Some bioplastics are biodegradable, which means they can break down naturally under certain conditions, reducing waste and promoting a cleaner environment.
Hi everyone, my name is Divagan son of Parthiban. My matrix number is 2411411859. Okay, let's go into my topic, which is evaluation of environmental impact of using bioplastic. I divided this into 2 points, which is benefits of using bioplastics and challenges that can occur if not using bioplastic. Okay, the first benefit is by using bioplastic, it can reduce dependency on non-renewable fossil fuels and lowering the carbon footprint. Secondly, it will utilize renewable feedstocks and contributing to a more sustainable production cycle. Next, it also has a potential to reduce greenhouse gas emissions during production and degradation, because this greenhouse gas emission, which is releasing carbon dioxide, we can harm the environment. And lastly, it will promote efficient use of natural materials and reduce resource depletion by utilizing agriculture byproducts. Next, we go into the challenges that can occur if not using um, bioplastics. Okay, the first is by not using bioplastic. If not using bioplastic, it can compete with food production, potentially leading to deforestation, biodiversity loss, and water scarcity. And next is agriculture process for feedstock like corn or sugar cane involve fertilizers and pesticides which can harm the environment and release greenhouse gases such as nitrous oxide. And not all bioplastic degrade easily in nature environments, and many require industrial composting. Next is improper disposal also can contaminate traditional recursive streams, and some bioplastic may contribute to microplastic pollution if not fully degraded. And lastly, production of bioplastic may require significant energy inputs and potential offsetting environmental benefits. Well, we have two types of plastic, which is conventional plastics and bioplastic. There are so much difference between conventional plastic and bioplastic. So here was the comparative between conventional plastic and bioplastic. Okay, when we saw by the source, the conventional plastic is sourced from fossil fuels, while bioplastics is from renewable resources. The carbon footprint for the conventional plastics is high compared to bioplastic because bioplastics is lower carbon footprint in production. Okay, next, by seeing the degradability, the conventional plastic is no non-biodegradable, while bioplastic is biodegradable. The waste management for the conventional plastics is widely recyclable but underutilized, while bioplastics is limited recycling and industrial composting. And the last is the production impact. For conventional plastic, the extraction and refining cause environmental harm, while bioplastic may involve land use and agriculture impact. Well, these are the pictures of conventional plastic and bioplastic. By see the picture itself, we know the difference between conventional plastic and bioplastic. By using conventional plastic, it will release greenhouse gas emissions such as nitrous gas and gas carbon dioxide, which can cause global warming because these gases help to trap the sunlight and keep trap the sunlight to the earth and keep the earth warm. While by using the bioplastic, we can reduce the greenhouse gas emission and it will not harm the environment, and we can save the environment from these pollutions.
Hello everyone, my name is Divya Prabha, Dr. of K. Shankar. My metric number is 2411411860. Today, I want to talk about social and health impacts of bioplastics. Bioplastics are made from renewable resources like corn and sugarcane, and they are designed to address pressing social and health challenges. But their impact goes beyond just being eco-friendly. They have significant social and health implications that deserve our attention. Let's start with the social impacts. One major advantage is that bioplastics promote environmental awareness. By reducing reliance on fossil fuels, they encourage sustainable practices and inspire eco-conscious lifestyle. They also contribute to job creation, particularly in agriculture, where crops like corn and sugarcane are grown, and in manufacturing industry focused on bioplastic production. This provides economic benefits, especially in rural communities. Furthermore, bioplastic ability to reduce landfill waste depends on the availability of proper composting facilities, which many regions still lacks. These challenges highlight the need for better infrastructure and public policies to support bioplastic. Now let's move to the health impacts. Bioplastics are generally safer than conventional plastics because they avoid harmful additives like BPA. This makes them a better choice for food packaging and consumer products. Additionally, their production process emits fewer greenhouse gases, improving air quality and reduce health risks like respiratory issues. But there are concerns too. If not disposed of properly, bioplastics can release methane during decomposition or break down into microplastics, both of which can harm human health and the environment. In conclusion, bioplastics hold a great promise for a more sustainable future. They reduce toxicity, create jobs, and address waste challenges. To maximize their benefits, we need to tackle affordability, improve infrastructure, and manage potential risks efficiently. With research, education, and policy support, bioplastics can truly transform the way we think about sustainability and health.
Let's go into the incorporation of circular economy principle by using bioplastic. First is sustainable feedstock utilization. A key circular economy principle is the sustainable sourcing of raw materials. Bioplastics should prioritize second generation feedstocks such as agriculture residues, non-food biomass, or waste materials rather than competing with food crops like corn or sugarcane. Utilizing these resources reduce the environmental footprint of bioplastic production and support the efficient use of natural resources. Secondly, the design for recyclability. To align a circular economy, bioplastic must be designed for easy recycling. And this includes developing material that are compatible with existing recycle system to minimize contamination. Secondly, enhancing the recyclability of bioplastic by reducing additives or coatings that hinder processing. And thirdly, incorporating clear labeling to guide consumers and recycling facilities on proper disposal. Third is biodegradability in appropriate context. While biodegradability is often seen as an advantage, it should be promoted for application where recycling is impractical, such as single-use items in agriculture or marine settings. Compostable bioplastic designed to degrade in industrial composting facilities should be prioritized in such cases, provided the necessary infrastructure is available. This ensures that materials reintegrates into natural environments as nutrient without contributing to pollutions. The next point is product longevity and reuse. A circular economy encourages extending the life cycle of materials. Bioplastics should be engineered for durability in application where long-term use is required, such as packaging, textiles, and automotive parts. Durable bioplastic reduce the need for frequent replacement and minimizing resource consumption and waste. The fifth point is integration into waste management system. The effective incorporation of bioplastic into waste management system is critical, and this involves establishing dedicated collection and sorting system for bioplastic to prevent contamination of traditional recycling system. Secondly, it will expanding industrial composting infrastructure to process biodegradable bioplastic. And lastly, it will promoting consumer awareness of proper disposal method to ensure bioplastic are managed sustainably. The next point will be is life cycle assessment, which is called as LCA. A comprehensive life cycle assessment is essential to align bioplastic with circular economy principles. By analyzing the environmental impact of bioplastic from production to disposal, manufacturers can identify areas for improvement, such as reducing energy use, optimizing resource efficiency, and minimizing greenhouse gas emissions. And the last, not the least, the point is collaboration across the value chain. A circular economy for bioplastic requires collaboration between stakeholders, including feedstock suppliers, manufacturers, policymakers, and consumers. Policies and incentives can encourage business to adopt sustainable practices, while consumer education campaigns can promote responsible use and disposal of bioplastic.
Bioplastics are increasingly being integrated into various industries, offering sustainable alternative to traditional plastic. In the packaging industry, bioplastic like polylactic acid, in short PLA, are used to create items such as flexible film, rigid containers, and so on. These materials help to reduce plastic waste and lessen our reliance on fossil fuels. In the automotive sector, is also adopting bioplastics for their interior components such as dashboard, cover seats, and so on. This shift not only decreases the environmental impact of vehicle manufacturing, but also promote the use of renewable resources. In the agriculture, bioplastics are utilized in composable films and plant pots, which enhance the soil health and reduce the accumulations of conventional plastic waste in the farming practices. This example highlights the versatility and environmental benefits of bioplastic across different applications. The production of bioplastic from cornstarch involves several key steps. First, corn kernels are processed to extract starch. This starch is then broken down into simpler sugar through hydrolysis. Next, microorganism forms this sugar to produce lactic acid. Through polymerization, lactic acid molecules are linked together to form polylactic acid, or in short PLA, which is one of the type of bioplastic. Finally, the PLA is processed and molded into various products suitable for application such as packaging materials and so on. This process demonstrates how renewable resources can be transformed into sustainable materials, reducing our dependence on fossil fuels. Now, let's watch an animated video that illustrates the bioplastic production process from cornstarch, providing a visual understanding of each step we have discussed.
Have you ever wondered how corn turns into bioplastics? Let's dive into the journey of cornstarch becoming an eco-friendly alternative to petroleum-based plastics. It all starts in the fields, with corn kernels being harvested. These kernels are processed to extract starch, the primary raw material for bioplastics. The starch undergoes hydrolysis, breaking down into simpler sugars. These sugars are fermented by microorganisms, resulting in lactic acid. The lactic acid is then polymerized to form polylactic acid, or PLA. PLA is a versatile biodegradable polymer perfect for packaging materials. Imagine corn can help reduce plastic waste and protect our planet. Thanks for watching.
While bioplastics have numerous environmental benefits, there are several challenges that need to be addressed. Technologically, many bioplastics have lower mechanical properties compared to conventional plastic, such as reduced tensile strength and thermal stability. These limitations can restrict their use in applications that require higher durability. Economically, the production costs of bioplastics are generally higher. This is due to factors like expenses of the raw materials and specialized processing requirements, which make them less competitive in the market. From a regulatory perspective, the lack of standardized terms like biodegradable and compostable can lead to market confusion and hinder their development of effective regulations. Environmentally, the cultivations of biomass for bioplastic may compete with food productions for land and resource making, which raise their potential impact on the biodiversity. So, addressing these challenges require collaborative effort in research, policy making, and industry practices to pave the way for a more sustainable bioplastic industry.
Let's continue to the other slide, which shows further opportunities for improvement in bioplastics. First and foremost is performance and properties. Bioplastics often face limitation in mechanical strength, thermal stability, and barrier properties. Many bioplastics are not as durable or strong as conventional plastics, which restrict their use in heavy-duty and industrial application. Similarly, their limited resistance to heat makes them unsuitable for high-temperature packaging or industrial processes. Additionally, bioplastics generally have poorer barrier properties against oxygen, moisture, and other gases, which can impact the shelf life of packaged goods. To address these issues, researchers are working on polymer modifications, blending materials, and incorporating nanotechnology to improve the properties of bioplastics and expand their applications. Now, let's talk about cost effectiveness. One big challenge for bioplastic is that they cost more to produce than the regular plastics that are made from petroleum. To make them cheaper, we need to improve how they are made, use better biocatalysts, and make the most of the materials we use. Another issue is that the cost of renewable materials like crops can change a lot, which makes bioplastics less reliable in terms of price. To solve this, we can use a wider variety of materials such as leftover agriculture waste, algae, or even carbon dioxide to make production more stable and affordable. Now, let's talk about cost effectiveness. One big challenge for bioplastic is that they cost more to produce than regular plastics made from petroleum. To make them cheaper, we need to improve how they are made, use better biocatalysts, and make the most of the materials we use. Another issue is that the cost of renewable material like crops can change a lot, which makes bioplastics less reliable in terms of price. To solve this, we can use a wider variety of materials such as leftover agriculture waste, algae, or even carbon dioxide to make production more stable and affordable. Another crucial area is biodegradability and compostability. While one of the biggest advantages of bioplastics is their ability to biodegrade, it's important to control the rate of degradation. We need bioplastics that can remain intact during the use and degrade efficiently under specific environmental conditions. Additionally, harmonizing compostability standards globally is crucial. Uniform standards can ensure proper disposal and recycling and helping to integrate bioplastic into a circular economy. Now, let's focus on sustainability and environmental impact. To ensure bioplastics truly benefit the environment, we need comprehensive life cycle assessment. This assessment identifies environmental hotspots across the production and disposal stages and help optimize the process. Moreover, effective strategies for recycle and reusing bioplastics are vital. By promoting a circular economy approach, we can minimize waste and make the most of the available resources, further reducing the environmental footprint of bioplastics. Finally, let's consider consumer awareness and acceptance. Public support and understanding are essential for the success of bioplastics. Educating consumers about their benefits and limitations can drive demand and encourage responsible consumption. Clear labeling and certification schemes can also help consumers make informed choices, fostering trust in bioplastic products. Now, I would like to highlight some exciting ongoing research efforts. Scientists are exploring new bio-based monomers and polymers derived from renewable resources such as agriculture waste, algae, even carbon dioxide. Advanced technologies like enzyme, catalysts, and chemical modifications are being used to enhance the performance and the sustainability of the bioplastics. Beyond packaging, bioplastics are being developed for innovative application in automotive component, electronics, and medical devices. Collaboration between researchers, industries, and policymakers is the key to accelerate these advancements.
Finally, I will discuss about conclusion overall of our project. Firstly, reduce environmental impact. Bioplastic help reduce our reliance on fossil fuels and lower greenhouse gas emission compared to traditional plastic. Then, promotes a circular economy. They support a circular economy by being recyclable, which minimize waste and maximize resources use. Then, enhance resource efficiency. Bioplastic utilize agriculture waste, reducing the need for new materials and managing waste effectively. Next, supports climate change mitigation. By lowering emissions, bioplastic align with global sustainability goals, helping combat climate change. Lastly, encourage innovation and job creation. The bioplastic industry fosters innovation and creates new job opportunities in agriculture and manufacturing. In summary, sustainable bioplastic production is essential for a healthier planet and a sustainable future. That's all for me. Thank you.